Welcome. In this session, we are going to look at one more economics concept that can be defined as a rate of change or a derivative. The marginal revenue product is defined as the effect on revenue of increasing the labor input by 1 unit. Let's denote the number of units of labor used as M. Now, this directly affects only the output, Q. Now, if everything produced is sold, then revenue will be a function of the quantity sold. So a function of quantities produced. So R is a function of Q. Typically, we will find this using the demand equation, which gives a connection between P and Q. And revenue, of course, is price times quantity, or P times Q. Then Q is a function of M, R is a function of Q. So by composition, we can express R as a function of M. And we can use the chain rule to find dr over dm, the rate of change of R with respect to M, which mathematically is the marginal revenue product. So dr over dm is dr over dq times dq over dm. In a typical calculation problem, like in the example we are about to do, Q is given as a function of M. In our problem, Q is 100M over square root of M squared plus 19. Then we have the demand function in this problem, P equals 4500 over Q plus 10, and I have to find the marginal revenue product, dr over dm, at some level, in this case M equals 9. So we start by finding dq over dm. I will write Q as function of M using fractional exponents, so I can apply the rules of differentiation. Q is 100M divided by M squared plus 19 to the power 1 half. So since it's a fraction, I'm going to use the quotient rule. The numerator is 100M, its derivative with respect to M is 100, times the denominator M squared plus 19 to the power 1 half, minus the numerator 100M, times the derivative of M squared plus 19 to the power 1 half. It's power of an expression, so I have to use the power rule and chain rule together. First, I differentiate for the exponent 1 half, which gives me 1 half times M squared plus 19 to the power negative 1 half, multiply it by the derivative of what's inside the parenthesis, that's M squared plus 19's derivative is 2M, divided by square of the denominator of the function I'm differentiating. Let's leave it at this point. We will take care of it afterwards. Let's find dr over dq next. R is P times Q. P is 4500 over Q plus 10. So in this problem, R is 4500 Q over Q plus 10. Again, I have a fraction, so I have to use the quotient rule. This is more straightforward because we just have to use quotient rule and we're just differentiating a rational function. The numerator is 4500 Q, its derivative is 4500 times the denominator Q plus 10 minus 4500 Q, the numerator, times derivative of the denominator denominator is Q plus 10, its derivative is 1, whole thing over Q plus 10 quantity squared. Now we are going to evaluate this when M is 9. So for dq over dm, I'm just going to plug in 9 for M and then calculate it. This is just simple arithmetic. The answer is 19 over 10. When we look at dr over dq, we see that we need to know what q is. So I need to evaluate q first, which is what I did here. When M is 9, you have to find q, you plug in 9 for M in q. That gives me 100 times 9 divided by 9 squared plus 19, quantity to the power 1 half, which simplifies to 90. So dr over dq when M is 9 is same as dr over dq when q is 90. So we are using the fact that substituting a number and then evaluating the outside function is same as evaluating the composition at the given number. This just avoids having very long and complicated expressions to work with. Now plug in 90 for Q in the marginal revenue, dr over dq. That comes out to be 9 halves. Now We have very simple arithmetic left to do. dr over dm is dr over dq times dq over dm. We have calculated each product, so we multiply them. This concludes our look at the chain rule, and we will talk about exponential and logarithmic functions in the next chapter.